In number 31, we're going to prove using composition that g of x is the inverse of f of x. So if you remember right, if g of x and f of x are inverses, then if I compose them, then I will just get x back, or whatever, the input back. So what we're going to do is find f of g of x. So instead of the x, I will write the function g of x. So the only thing I replace right now is replace this x, replace all the x's with x minus 5 over negative 2. And then I just will simplify. So my negative 2's will cancel here, so I'll use red for that. Negative 2 cancels with that negative 2, which leaves me with x minus 5 plus 5. But addition is associative, so I can rewrite that as x minus 5 plus 5, like this, and then I'm left with, well, it's like a plus minus negative 5. We're not left with just x. And now for the other direction, so now I can see that f will undo g of x, but I need to make sure that g of x will also undo f of x. So I need to go the other way. So this time I'm going to do a g function and evaluate it when x equals f of x. So in place of all the x's, both those x's, I will write the function f of x, which in this case is too big to fit into that parenthesis. Negative 2x plus 5 and now it's just a matter of simplifying that, and I can see that positive 5 and the negative 5 will cancel, and I'm left with negative 2x over negative 2, which gives me x. So now that I've proven that the composition functions of f of g of x and g of f of x are both x, this is an inverse. So this means, in conclusion, g of x equals f, the inverse of x. Of f, sorry.